Hi guys, I'm just trying to record a video so that I can go through some of the command um, instruction, I mean to say, on how to convert these instructions into the binary form. And some people still had a problem like in understanding which is going to be the source register, which is going to be the destination register. So just to clear more further and to be 100% clear with this concept, I'm going to explain you that the command like add u, okay, and add this one, add this command, okay, these are R type, register type, okay. So these R types generally at your bottom of your question paper they will give you a reference code for this, that for register type what is going to be the reference. So let's say, like it'll be given in like O, then SSS, like that, which is given there. So I just instead of copying that one, I just making it to more clear that, see, this is how you're going to write it. The first 6 bit in the R type will be known as opcode, and for both the command like add u and for add, as I told you in the class, is going to be 0, and if it's going to be also explained to you in the reference paper. So this is going to be 0, and the shift amount 5-bit in the middle, okay, shift amount, this also has to be all 0, 5 0. So the only thing you just need to concern about is these three things and this one. Now just to make it clear, like, okay, which is our source register, which is our here. So let me make you understand here that this is the first source register. So you can see RS meaning register source, okay. Now the next one is called RT. Now RT meaning is second register, second source register, but they gave a name actually. RT here is called as transition register. In other words, but for you all people to understand, just remember that RT or register T, okay, is known as second source register, and RD is known as destination register. So there's nothing to confuse about it. This is source, this is destination, so definitely this is second source, okay. And this is the function one, function register. Now for this function, for add u and add, if you go to the last bottom of your reference paper, okay, function register you can get for this one. So now let me use somewhere here. So let's see if this is the command. It's very easy to understand that the first source register is this one, okay. You know what's the meaning of this? You're saying, okay, add this one plus this one and add it and give it the answer in what? R2, okay. So, and even in this command, so you're saying, okay, add this one and add in this, give me the answer in this one. So basically this one, okay, is going to be the destination register. This is also going to be the destination register, which I showed you that this is destination register, that is going to be referred as RD. And then the first one, which you can see from here, that's what's called source register and is referred as RS, okay. So this is source register, and this is second source register, which we are calling as RT, okay. So it's referred as RT, but remember this is first source, second source, and this is destination. So similar here, first source, second source, and this is destination, okay. So now when we come into the command here, so just like how we want to work in this one is so easy. Like for example, I'm going to explain you again here. If you can see here, 6 register, 6-bit for the opcode, so meaning I told you is going to be all 0, okay. Now let's do it this way, okay, just like give a space, let's go this way. Now source register for this command is T0, which is 8, okay, the number associated with this T0, because every register has a number, you can check it in your reference manual. So this is T0 is 8, okay. So if you convert 8 into binary, okay, it'll be 1000, but they said it has to be 5-bit, so let's add another 0 to make it as 5-bit. Now this is the second source register, so second source register is T1, and T1 is according to the number, which if this is 8, this is going to be 9, and the binary of 9 it will be, if you see the binary of 9 will be 1001. So this is binary of 9, but it has to be 5-bit, so add another 0 to make it as 5-bit. Now for the destination, okay, is your destination is T0, which is the number is 10 associated with this. Okay, so let's see if I want to go if I want to get the binary of that destination 10, 10 will be what, like 1 0 1 0, so 1 2 4 8, so yeah, that's 10. So if I add another 0 to make it 5-bit, and now for the shift amount, I already told you that it has to be 50 automatic. And then you go bottom of your reference manual, you see the function register for add u. Okay, it'll be like a rectangle, it'll be like a rectangle box, like a matrix box right at the last of your page. And if you see the function code for that, it'll be 100001, something like that. Okay, so now if you combine it all together, this is what you're going to get the binary. Yeah, this is what you're going to get the binary. So if you see this one, 1 2 3 4 5 6 7, so 2 4 6 2 4 6 7 0. Okay, then 1, then you have 1 2 3 4, then 1 2 3 4, then 1 0 0 1 1 0 0 1, then 0 1 0 1 0 0 1 0 0, and then again all that thing, and then so you see exactly the same thing. So either you can leave the answer like that, or you can just make it. I think I'll prefer you all to leave the answer like this, so that it makes clear and easy for you, as well as for whoever marks it. It'll be easier for them to understand the thing. Okay, so now try this question, exactly the same thing, and again the opcode and the shift amount for this question also will be 0. Okay, the only thing you're going to work with is source register, second source register, destination, and the function code. Okay, now but be careful, this is not T1 and T2, is S1 and S2. So you just have to see what is the number associated with T1. If you want to see, you can even search in your online. Okay, you can say MIPS register, and if you go into the image, and anyway if you go to the register, so if you see this one is S1. So for example, the question is S1 S2 and T0. T0 we know is 8, but less for S1 S2. So S1 is from here, if you see S1, so S0 is 16, so S1 is 17. Okay, and S2 will be 18. So you need to get the binary of so this will be source register, and get like the number of that. So again I'm repeating it, S0 here is 16, so here is S1, so that means this is 17 and this is 18. Okay, so convert the 17 in binary and make it 5 bits, so that S1 will be coming as, you can say, in this area, and the S2, which if you convert this into binary, you'll get in come in this area, and the destination one T0, which is again 8, is going to come up in this one, and the shift amount is going to be the same. Function register, go right at the bottom of the matrix, there is a matrix, and you can see the whatever the code is, you just put it up, and this is your final answer. So hope so you can confidently build up this answer and should be having any problem. Okay, so check it out nicely. Now you know, like there are some zero gap here, but I prefer you don't worry with the zero, like gap. Do in this way, so you can understand that this is okay. Opcode 6-bit, source, second source, destination, shift amount, and the function. Now this too was easy. Be clear with this. Again I'm repeating that this is your first source, this is your second source, and this is your destination. Okay, in this question it's almost same, but be careful, this is S1 and S2. So $T0, if you go to the register map, T0 which is 8, but for S1, S0 start from 16, so S1 is 17 and S2 is 18. Okay, so make sure you can get 17 and 18 binary and put it in this two area. Okay, now this is only for add u. I haven't done for add one, so you need to do yourself. Now coming to the next two questions, LW and SW. Now there was a quite of confusion, okay, which is going to be source, which is going to because according to the working, I told like, okay, this is going to be the source, this is destination, and for this one I said is going to be different, but no, I think according to the manual online, I checked it is like and it's good, is easier for both the command. This one and this one is the source for both command. This is source, and the front one is the destination. So it's easy to understand and I don't think so we are going to make a mistake here. So again, I'm repeating it for both the command. This and this one is going to be the source, and the front one is going to be the destination. And one thing make clear that LW and SW are both I type. So if you see the map of the format of I type is 6-bit is the opcode, 5-bit is the source. So source is meaning is this front one, and RT the destination, which is the front one. Okay, and IMM is the immediate code, which is 16-bit, and immediate is this number. Okay, so you need to convert this number into binary. Okay, so if once you convert into binary and if you see it's not coming in 16-bit, you add extra 0. Let's say you converted 2000. When you convert 2000 in binary, you will get something till here, but this is not 16-bit, it's 4, 8, 11. So to make it 16, you have to add another 50 to make it 16, and you have to do it. So that's why it is saying 16-bit. If you don't add this extra 0, you'll be getting a wrong answer, and marks will be deducted according to that. Now, so let me repeat again. So this 2 is called the source register, this is called the destination register, and these are called the immediate value, IMM. Okay, and the 6-bit code you have to get it. So how you're going to do this is when you go into your reference manuals, find out what is the opcode for LW. Now I found out is this one, so I just copied it. So you do in this way, like you don't have to make in any order, just like let's put this way, then I put a gap, so that 6-bit is coming up here. Now they're saying for source register. Now we know that source register is dollar. Now if in your exam, if it is like 9 is wrong, you can take $T1, $T2, $3T, whatever you can take this one. You can take anything you feel like. You can take $T1, $T2, and according to that you can generate, you find the number and you can do it. Okay, but I'll just suggest to you, like if this is T0, so if this is T9 for example, let's just take it as T1, $T1. So according to the manual, if you come up here, T0 is 8, so T1 will be what, 9. So what we're going to do this, if you convert the binary of 9, okay, is 1001, but it's not 5-bit, so I added 0 to make it this. So see, the source part done. Now if you come to the destination one, destination is T0, which is 8, right? And 8 binary is 1000, so I added another extra 0 to make it 5, so that part done. And now this 16-bit, this one is very easy. See, the immediate number is 2000, so convert into binary. Okay, you can use your calculator, convert into binary. So when I converted the binaries from year to year, okay, I added extra 50 to make it 16-bit, so job done, finish. Exactly the same thing you need to do for this, but I'm repeating again. What you do for SW, just go and see the opcode at the bottom of somewhere in your paper. So I saw the SW and I got this answer from there. So see, 6-bit done. Now they are saying source register. So I again told you for this command, again the source register is this side on your right hand side, similar like the LW, there's no difference. So they're giving you T1, and T1 is 9. Okay, so I converted into 9, and this is binary of 9 is this, so I add in an extra 0 to make it as 5-bit. So see, done. Now this is RT, which is your destination. Now here RT mean destination, so destination is this side one. Okay, so destination is now don't get confused with RT. There you told me is transition, that's fine because they had 3 register there, so that's why we calling as first source, and that RT is called second source and destination. But when you have 2, then this is your source, and RT, this one is called the destination. So here the RT T0 is what, 8, so I got the binary of 8, again the same thing, and I added 0 to make that one. And again immediate value is 1205, so I converted that one, which I got is this much till there, added another 50 to make it 16-bit, and that's it. So the only thing, what am I making it clear again, very important, this is called the source register, which is known as RS, and in this one, this 2 is called the destination, which is called RT here. Okay, there won't be any third register. and this is immediate value. So both right hand side is source register, both on our left hand side is your destination register. And in your exam, if you see something done like $9 or $2, $3, okay, it can't be $2, like it should be either T2 or T3, T4. So here you have your good option, like you can take anything. You can take it T1. I did it with T1 here. You understand? So T1 is your source. So I took T1 is 9 and I did it here. So you can take it 10, sorry, $T2, $T4, T5, but declare it. Say I took this one and then get the binary according to that one. Okay. Any questions? You can just leave an email to me and I'll get back to you. Okay. So any question, any other question, just email me up. Hope I made you clear with this one. And good luck to you all, guys. Okay. Thank you.